Want to fully optimize your PC, boost FPS and reduce input delay? In this video, I'll cover the 10 most effective optimizations to help you get higher FPS and better overall performance. After applying these optimizations, you'll clearly notice the difference. We're starting with something Windows normally does to help when memory starts getting tight: memory compression. Open Windows Search, type PowerShell, right-click it and choose Run as Administrator. Before changing anything, enter Get-MMAgent. Press enter and look for memory compression. If it shows true, Windows is currently compressing memory. To switch it off for testing, enter Disable-MMAgent MemoryCompression and press enter. Memory compression can be useful because it tries to keep more data inside RAM instead of immediately pushing it to the page file. The trade-off is that compressing and decompressing that memory also uses CPU resources. So if you have around 16 GB of RAM or more and your games are suffering from inconsistent frame times, this can be worth comparing. If you only have 8 GB of RAM or you regularly run close to your memory limit, don't assume disabling it is automatically better. In that situation, memory compression may actually help your system avoid heavier paging. Now we're going after something that matters a lot in CPU-heavy games: how quickly your processor decides to boost. Open Command Prompt as Administrator and run PowerCfg, attribute sub, processor PERFBOOSTMODE, attrib, hide. This doesn't overclock your processor. It simply reveals an option Windows normally keeps hidden. Open Control Panel, go to Power Options, click Change Plan Settings next to your active plan, then open Change Advanced Power Settings. Expand Processor Power Management. You should now see Processor Performance Boost Mode. Desktop users can test Aggressive. If you're on a laptop, start with Efficient Aggressive, because full aggressive boosting can increase temperature, fan speed, and battery usage. Think of this setting as the CPU's reaction mode. When a game suddenly becomes busy, the processor may need extra performance almost instantly. If Windows responds too slowly, you can see a short FPS dip or low GPU usage while the CPU catches up. A more responsive boost policy can help the processor react sooner when that sudden load appears. Next, if you want to fully optimize your PC with just a few clicks, even if you know absolutely nothing about PC optimization, you can use TweakShift AI Engine. It uses AI to analyze your PC hardware and your selected gaming goals, then recommends the most compatible and effective optimizations for your system. You can try TweakShift AI Engine for free with limited tweaks unlocked. But if you want full access and don't want to keep paying someone hundreds of dollars every time you need your PC optimized, you can unlock the full version. Check the link in the video description and try TweakShift AI Engine today. There's another hidden CPU setting right beside this one, but it controls something slightly different. Go back to Command Prompt as Administrator and run PowerCfg, attribute sub, processor PERFINCPOL, attrib, hide. Return to Advanced Power Settings, Processor Power Management. Look for Processor Performance Increase Policy. If your system offers Rocket, start by testing that. Some Windows versions use different labels, so if Rocket isn't shown, choose the fastest performance response option available. Boost Mode decides how aggressively the CPU can boost. Increase Policy decides how quickly Windows asks it to move toward that higher performance state. That difference matters when game load changes instantly. For example, when a new area loads, several players appear, or physics and effects suddenly kick in. Now let's change the balance Windows uses between efficiency and raw CPU response. Open Command Prompt as Administrator once more and run PowerCfg, attributes, sub, processor perfab, attrib, hide. Go back into Processor Power Management. Look for Processor Energy Performance Preference Policy. If the setting appears, move it toward maximum performance. On systems that show a percentage, that generally means testing 0%. This tells Windows that during this power plan, we care more about fast processor response than saving a small amount of energy. You may not see a dramatic average FPS change from this alone, but if your CPU has been constantly trying to balance gaming load against energy efficiency, it can affect how responsive the whole system feels. Now let's remove one Windows-powered feature that can directly affect the devices you use to control the game. Expand USB settings. Open USB selective suspend setting and set it to disabled. Click Apply. Windows normally uses this feature to place unused USB devices into a lower power state. That's useful for saving power, but on a gaming setup we want the mouse, keyboard, controller, headset, USB audio device and other important peripherals ready all the time. Here's the only registry adjustment in this setup. Open Windows Search, type Registry Editor, right-click it and select Run as Administrator. Paste this path into the address bar. HKE, Local, Machine, System, Current Control Set, Control, Priority Control. On the right, find Win32, Priority Separation. Double-click it, choose hexadecimal and enter. 26. If the value is already present, we're simply editing it. This setting changes part of the way Windows distributes processor scheduling between the foreground application and background work. For a gaming-focused setup, the idea is to give the active application more responsive scheduling behavior without pretending this registry entry somehow creates extra CPU power. Treat it as a scheduling test, not a guaranteed FPS multiplier. Once the value is set, close Registry Editor. Now let's remove background storage activity from places where Windows doesn't really need to be searching while you're gaming. Open Windows Search and type Indexing Options. Click Modify. Go through the indexed locations and remove large game libraries, recording folders or other huge directories that you don't need Windows Search scanning constantly. For example, if your Steam or Epic library contains hundreds of gigabytes of game files, there's usually little reason to have every file inside those folders indexed. Click OK once you're done. If you want to take this further, open this PC, right-click your game drive and choose Properties. At the bottom, you may see Allow files on this drive to have contents indexed in addition to file properties. You can disable that for a dedicated game drive and apply the change to its folders and files. This process can take some time on a large drive, so don't start it 5 minutes before you want to play. The purpose here is simple. Reduce unnecessary disk and CPU activity while the game itself is trying to stream files. One setting I never recommend disabling just because somebody online called it a gaming tweak is the page file. Open Windows Search and type View Advanced System Settings. Under Performance, click Settings. Open the Advanced tab and click Change under Virtual Memory. For most systems, keep Automatically Manage Paging File Size for all drives enabled. If you prefer controlling the location manually, keep the page file on a fast SSD or NVMe rather than an old hard drive. What I would not do is completely disable it. The page file is not extra RAM, but Windows and many applications still expect virtual memory to be available when physical memory demand suddenly spikes. A badly configured or disabled page file can turn a temporary memory spike into stuttering, instability, or even a crash. For most gaming PCs, system managed on a fast drive is the safest setup. There's very little reason to copy random fixed page file numbers from another person's PC because their RAM usage, storage, and workload may be completely different from yours. We've changed 9 things, but the 10th optimization is what decides whether any of them are actually useful. Benchmarking correctly. Before you call any tweak a success, test the game under repeatable conditions. Once all the changes are applied, restart the PC. That restart is important because we changed memory behavior, hidden processor policies, power settings, scheduling behavior, indexing, and virtual memory configuration. After Windows loads again, run your test under the same conditions you used before. The goal isn't to turn every setting to maximum performance and hope for the best. Keep the changes that make your system perform better. If this video helped you get smoother and more responsive gameplay, drop a like and I'll see you in the next one.